This is differential equations, section 3.4, activity 342. There must be some sort of typo. So instead, I'm going to do questions 1 and 5 from the homework. So in 1 and 5 from the homework, we have this setup. X prime is 2x plus 2y. Y prime is negative 4x plus 2y. And so notice it's not in the nice format. So we need to kind of do, we need to work it out algebraically. So let's begin. So A is 2, 2, negative 4, 2, right? So eigenvectors, so determinant of 2, 2, negative 4, 2 equals 0. Oh, I need minus lambdas, sorry. Just forgot those. So then I've got 2 minus lambda times 2 minus lambda minus a negative plus 8 equals 0. So I have lambda squared minus 4 lambda and plus 4 plus 8 so plus 12 equals 0. Okay, so then lambda equals, let's see, negative b plus or minus square root b squared minus 4ac all over 2a. So lambda equals 4 plus or minus the square root of 16 minus 4 times 12. 16 minus 48 would be negative 32. Right? 16 minus 48. Yeah. Negative 32 all over 2. So there's a factor of 4 inside that negative 32. Usually there's a factor of 16 inside that negative 32. So this would be more like 4 plus or minus 4 times squared is negative 2. So then this is equal to, I can divide by the 2 then. So 2 plus or minus 2 squared to 2 times I. Okay. Now we need to know the eigenvectors. So here, notice that real part will cancel there. So when I subtract it from A, I have, let's do just the positive one, because everything's conjugates all work nicely with complex numbers. So just with the positive one, when I subtract it, I get negative 2 squared to 2i, that's 2, negative 4, negative 2 squared to 2i. Okay, so what are the Kyle numbers here? Well, let's see. So if I had a 1 here and a square root of 2 times I there, they would add up, if I multiply that times this column, that times this column, they would cancel out and add them together to cancel out. Those are the Kyle numbers. So then my eigenvector is 1 and square root of 2 times I. Okay, which goes with the plus. Which goes with the 2 plus 2 squared root of 2i. Okay. So now, let's find the eigen. So then the complex system then is x of t equals e to the this eigenvalue times t. I'm going to break it up into 2 parts, the 2t, and then e to the 2 squared to 2i t times the vector 1 square root of 2i. Okay? Well, that's, now we use Euler's formula. So that's equal to e to the 2t times cosine of 2 squared to 2t plus I sine of 2 squared to 2t all times the vector 1 square root of 2i. Okay, so now we want to break it up into and its conjugate, where you have the negative I there, the negative I there is the other solution. So we want to break this up into its real part and imaginary part. So its real part is real times real and imaginary times imaginary. So x real of t equals e to the 2t times cosine 2 squared to 2 times t. And on the bottom would be negative square root of 2, because the I times the I would be negative 1. That made it negative. And square root of 2 times sine of 2 squares of 2t. And x imaginary of t would equal e to the 2t times, and the imaginary parts would be imaginary times real and real times imaginary. So, and then drop the I on the outside. So, because it's just looking at the imaginary part. So sine of 2 squared to 2t, and then real times imaginary here would be square root of 2, and it's just leaving out the I, times cosine of 2 squared to 2t. And then any generic solution would be a c1 times that plus c2 times that. So then x of t equals c1 e to the 2t times that thing, cosine 2 squared to 2t negative square root of 2 sine of 2 squared to 2t plus c2 e to the 2t times sine of 2 squared to 2t and then square root of 2 times cosine of 2 squared to 2t. Okay. Here we go. Now, let's see. That's our generic solution. So we finished number 1. And now we need to do the initial value problem. So let's get a new piece of paper. So if x is 0, 2, negative 3. Because that's how the problem is stated. So then if I plug in 0, so x of 0 from what I get, that's c1 times 1 times plugging in 0 for the cosine gives you 1, then 0, plus c2 times 1 times plugging in 0 there is 0, and then plugging in 0 there gives me square root of 2. Okay, now I want it to be equal to 2, negative 3 with this initial value problem. Okay, well, in order to get that, I can use regular old algebra, or I can use Sage. So we'll restate this as just an algebra problem now. C1. Oh, this is really, C1 is equal to 2. It's all diagonal, so it's actually quite nice. And C2 equals negative 3 divided by square root of 2, which would be negative 3 halves times square root of 2. So then, because it was diagonal, because then zeros there and there, that made it really easy algebra. All right, so then my final solution is x of t equals 2 e to the 2t times cosine of 2 squared root of 2t, negative square root of 2 sine of 2 squared root of 2t, plus negative 3 halves square root of 2 times e to the 2t times sine of 2 square root of 2t times square root of 2 times cosine of 2 square root of 2t. All right, that completes problems 1 and